In this session, we want to talk about some properties and features of the virtual network adapter. We're going to right-click on the VM and we're going to click on Settings. We want to select the network adapter. So we're going to click the plus sign to the left of network adapter to expand the network adapter. And we want to look at some of the settings on the network adapter. For the virtual switch, we can always click the down arrow and we select the switch that we want. Remember that the switch is created under Virtual Switch Manager. If your host computer, this is the Hyper-V server, is connected to a physical switching infrastructure that uses VLANs to create separate subnets, you can select Enable Virtual LAN Identification by clicking here in the checkbox, Enable Virtual LAN Identification, and you can enter an ID. The ID number can be 2, 3, 4, whatever the ID number is. That would allow you to associate the network adapter with a particular virtual LAN on your physical network. And then you have below that the option to enable bandwidth. This option allows you to control the amount of network bandwidth allocated to the network adapter. You have the minimum and maximum values for your bandwidth setting. And if you wanted to remove the network adapter from the virtual machine, you simply would click on Remove. Next, we want to look at the hardware acceleration settings. So we're going to click on hardware acceleration. Now, some physical network interface adapters have features that are designed to improve performance by offloading certain functions from the system processor to components built into the adapter itself. Hyper-V includes support for some of these features, as long as the hardware in the physical network adapter supports the features. Let us look at some of these hardware acceleration settings. The first one that we want to look at here is Enable Virtual Machine Queue, VMQ. And this is a technique that stores incoming packets intended for virtual machines in separate queues on the physical network adapter and delivers them directly to the virtual machines, bypassing the processing normally performed by the virtual switch on the parent partition. We also have the setting Enable Ipsec Task Offloading, where you can specify the maximum number of security associations you want the adapter to be able to calculate. Next, we want to take a look at advanced features. By default, virtual network adapters receive a dynamically assigned MAC address from the Hyper-V server, but you can opt to create a static, so you can click on static, and you can create a static MAC address by using the static option. And then below that, you have Enable MAC address spoofing. When this is enabled, the port in the virtual switch to which the virtual network adapter is connected can send and receive packets that contain any MAC address. And the virtual switch port can also learn of new MAC addresses and add them to its forwarding table. So the MAC address spoofing allows the virtual machines to change the source MAC address in outgoing packets to one that is not assigned to them. The next setting that we have here is Dhcp Guard. And Dhcp Guard prevents the adapter from processing messages sent by rogue Dhcp servers. So it will drop any Dhcp package that does not come from an authorized Dhcp server. Next, you have the Router Guard. The Router Guard drops router advertisement and redirection messages from unauthorized virtual machines pretending to be routers. Next, we want to look at port mirroring. And port mirroring allows the network traffic of a virtual machine to be monitored by copying incoming and outgoing packets and forwarding those copies to another virtual machine configured for monitoring. So we can simply click the down arrow and we can either say none, or we can put the destination or the source for port mirroring. To recap on the advanced features, we looked at how we can change to static for the MAC address. We also looked at how we can enable MAC address spoofing, which allows the virtual machines to change the source MAC address in the outgoing packets to one that is not assigned to them. We looked at Dhcp Guard, which, if it's turned on, will drop any Dhcp message from a Dhcp server that is not authorized to give out Dhcp addresses. We also looked at the Router Guard, and the Router Guard drops router advertisements and redirects messages from unauthorized virtual machines pretending to be routers. Port mirroring is one that we also looked at, and port mirroring allows the network traffic of a virtual machine to be monitored by copying incoming and outgoing packets and forwarding the copies to another virtual machine configured for monitoring. We also looked at hardware acceleration, where we were able to enable virtual machine queue and enable Ipsec task offloading. This is the end of our session, and I want to thank you for listening.